Hey everybody, this is Larry. This is day 20th of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Actually, that's funny because I was just looking at this problem because I've been working on on um a binary search video. So this one I think maybe, to be honest, I might keep it a little bit short just because I might end up using this problem anyway. So I actually do know how to solve this as a result, because wasn't it's very coincidental, but yeah, I do have one minor big news, which is that I have a new keyboard. So if it's a little bit clacky clack, let me know how loud it is, if it's or whatever. But yeah, but for this problem, yeah, I mean, I'm not gonna go over it too much, to be honest, because I'm going to have a video coming hopefully soon to kind of just go over how I solve binary search problems, because I solve every binary search problem more or less the same, and I feel like there are some details that I'm recording these live, and these are kind of like almost like a daily vlog type thing of me solving these problems, and one thing that I always find a little bit hard to do, to be honest, as part of these videos, is kind of figure out, like, the balance between going really deeply into a problem or or not as much, right? But because at this point I probably have like literally 100 videos on binary search, and it is like I ask myself, what is the returns on me explaining the same binary search, for example, as an example, every video, like, as in depth as possible, right? Like, I'm okay with being in depth, but at a certain point I'm just doing the same thing, and maybe I could do a special video on this instead. And these are kind of things that I've been thinking about. So this video may be a little bit shorter and maybe not as detailed, but the ideas will still be here, and we'll figure it out. Let me know what you think in the comments about my keyboard, my binary search way coincidental problem, and stuff like that. So yeah. Cool. Let's get started. So yeah, actually, I remember looking this up, or looking this problem, but I actually don't remember the details. So it will still be live a little bit. But yeah, and maybe this is actually a good warming, or not warming up, but preparation for that video. But yeah, so Koko loves bananas, as we all like bananas. The N piles, the I pile has piles. The gods have gone and come back. Can decide each hour some hours, and you came. Is that what all of them said? We're not getting more this hour. Okay. So yeah. So the first thing to notice for this problem is that maybe I won't use this one for the video just because it's a little awkward to kind of be so close about it. But the first observation about this problem is that it doesn't matter which order the order you eat the piles in, right? So you have something like this, and then let's say you can eat. Oh, you have to find K. Okay, but let's just say you have given you're trying to find, or you're trying to eat, say, 4 at a time, right? It doesn't matter whether you eat the 3 and from. It doesn't matter where you eat from the 3 first, and then the 6 twice, and then the 7 twice, and then the 11 3 times, right? Because the order doesn't matter. All that matters is that in total, sorry, still adjusting to the keyboard locations of stuff. I'm so used to my old keyboard. We've used it for, like, I want to say almost 10 years. So yeah, so now you have 1 day, 2 days, 2 days, and 3 days, right? And this, of course, sums to 8 days, and it doesn't matter whether you interlock or whatever, and you could kind of prove to yourself that this is the case. This will take 8 days, right? So here, one thing that I would like to do is to write a function of, okay, let's say we have the answer. Can we figure out a way to see how whether we can finish in 8 days, right? And there's different ways of naming it, but yeah. So then the first thing I would say is, let's say we have some target. I probably will explain this better in the binary search video, not to spoil that a little bit, but yeah. But let's say we have some target that we're trying to target, and I do use this. Okay, I don't want to be too sloppy on this one. I do want to do a technique called binary search on the answer, and and basically the answer can be any number from let's see, right? Let's figure that out. The answer in this case can be there's 10 to the 4th, each pile can be 10 to the 9th. So that means that the number of total piles, the number of total piles will be 10 to the 13th, right? So that means that, okay, so that means that the answer can be from, is it 0 or 1? One of those two, let's say. For now, it doesn't matter as much. 0 to 10 to the 13. So then here, we know that our sketch of an algorithm, this is going, let's say we have this magic function, which we will implement, and it's going to take a loop through the array every time. Then this is going to be O of n times log of the universe is what I call it, which is the size of this thing, right? Which is, of course, roughly speaking, I don't know, like O of, well, it's log of u in this case, even for 2 to the 64 is just 64, right? So let's just say I'm lazy right now in the math, and so then this is just going to be, roughly speaking, O of n times 64, and of course n is 10 to the 4, so this is the math for me to kind of figure out 10 times 10 to the 10 to the 4th times 64. So this is roughly an estimate for me to figure out whether I need to whether this is going to run in time, right? Okay, so now that we have that, we do a feasibility study, and then we go, okay, let's say we are given a target. What is the, and you can implement this in any way, but the way that I would implement this function, and I always label it good. Maybe it's not a good name for it per se, but maybe you could like, is yielding speed enough, right? Let's say this is, let's say we're given this target speed, and is this speed enough? And so then now we just count the number of days, right? Days is 0 for x in piles. Days we added, which is of course equal to x x divided by the speed that we're eating it, and then we want to round up, and of course in rounding up in discrete, this is how I would do it for rounding up in discrete. And then, oops, and I'm still not used to this new keyboard. They're like page up buttons in a weird place. Maybe I need a different keyboard. But yeah, and then now this is enough if the number of days that it takes to eat this is smaller or greater or less than h, right? So okay, so now we have this, and this is the function that we have, right? I think maybe I want to give this a try where I explain this backwards, right? Where, okay, now we implement this function. Now, instead of kind of asking the first true, the first or the last true or whatever, I have this function that I know I want to binary search on. So then the question is, what am I looking for, right? Am I looking for, and I actually don't use these terms because I don't think of it this way per se, but I think that's what a lot of people do, right? So then I go, okay, let me take a look at this property of this function, which is that, okay, let's say speed is equal to 1. What does that mean? Well, if speed is equal to 1, then this will be a lot of days, so it's probably gonna start off fast, and then as you kind of increase the speed, days goes down, right? So that means that analyzing this function, as days goes from a big number to smaller, this is going to be eventually it's just going to be force, and then it becomes small enough to be true, right? So this is the function that we're given, and this is just analyzing this function that we wrote. And of course, there are a lot of ways to kind of represent this in the negative way, which we'll talk about in a sec. But let's say that we run this function like this because that's for me the most intuitive way to write it. For you, you may write it differently, right? Maybe you'll write is the eating speed too slow, for example. It may look the same, and then you would maybe have a different operator here or something like that, right? But here, so now we're given this function, right? And what do we want from this answer, the question? So we read it again, maybe, or maybe you already know it without reading it again. Run the minimum case such that can eat all the bananas in 8 hours. That means that we want the minimum thing where this is true, because the speed enough. If the speed is good enough, then we do eat all the bananas. So that means that we want the first true, say, right? So we're trying to find. Oops. So we're trying to find this position, right? So, yeah, maybe that's good enough for now. For, find this, right? So that's basically our goal. And of course, like I said, you can use the vocabulary of this is first true. I don't really think of it this way, per se, and you'll see why in a second. So then now we declare our ranges. One thing that I sometimes is a little bit sloppy about is about the ranges, about the lower bound and the upper bound. It's very intuitive to do something like, let's just say this, but depending on the way you write it, it is critical to have, and maybe the way that I would like to write it anyway is to at least have one false in the range and one true in the range, so that things can be resolved a little bit easier, right? And what I mean by this is that, let's say you have a equivalent function where, running it for all your range, if you get true, in a weird way, you don't know that this is the first true, because in theory, maybe if you started too late, there were more truths to the left, right? So that's why I don't like doing it this way, or that's why I want to make sure that there is a false, so that, and sometimes that will take us out of bounds. Maybe it'll take us to -1 or something. I don't know if that's the case. Well, in this case, I don't think that makes sense, because if you have a eating speed of 0, this would go out of bound. So actually, we want at least 1. And then maybe we have to take care of it a little bit. But ideally, this is what I would like to do. And of course, the other case is true as well, right? If we have all 4s, how do we know that, this value is going to be true? We don't, right? So that's why I want to make sure at least one false and one true is in the bound, so that we can guarantee ourselves. That's where I make the most mistakes, to be honest. And here, yeah. So left is equal to 1 means that we're almost guaranteed to have a false, except for if H is like really big, I guess. So in this case, actually, we're really yeah, in this case, I guess we're actually a little bit sketchy on this part. You can maybe have a edge case of, okay, let's start at 0. If our speed is 0, then you could say maybe if speed is equal to 0, we have some infinity value, which will just have like, I don't know, something really big, right? So and this is less than H, of course, which means that I'm actually pretty okay with the home keys on this new keyboard, but the like arrow keys and stuff like that, I still have to get used to, because it's a little bit different layout. But yeah, and of course this ideally should be false, so we just return false. So that basically saves us time here to kind of figure it out. So we always have a false in the beginning, and given a fast enough speed, this is always going to be true. So I think maybe this should be good enough, but maybe we can add like a small number or something, right? Because that's the most number of things here, or something like that. Okay, so then now we this is a thing where you see some people as this or something like this. The difference is that one of them is in exclusive bound and the other is inclusive bound. I'm not going to go over the whys and hows, because I'm going to save that for that video. It's going to be a longer video and it will have a lot of details, hopefully. But if this is an inclusive bound, which leads to a couple of meaning, right? Because this is an inclusive bound, that means that this is our range, which means that every number inclusive of the left number and the right number is our range. That means that this becomes false when left is equals to right. We terminate, right? Terminate when this happens. So we terminate when this happens, so that means that the answer is going to be left, right? Because because when we terminate when it happens, we terminate when this happens, which is another way of saying now left right implies left is equal to left, which means that there's only one number in the range, our correct answer. So that's why I write it this way, right? And then here we just have mid is equal to left plus right over 2. At least that's how I write it to begin with. We'll go over some nuances, in the future, but this is just the midpoint of these two. In this case, we round down because it is discrete, and yeah. And to facilitate, so then now we go, if good of mid, and then now this is the part where we kind of figure out how to answer this, right? So let's say we have this thingy, and there are only two scenarios, right? One is, okay, let's say if this is mid is here, right? Let's say this is mid. If mid is here, if this is, okay, actually, I wrote it like this first, so it doesn't really matter, but let's say mid is here then, because this is, this is true. What happens if this is true? If this is true, then mid is a possible answer, right? If true, mid is a, okay, actually, let me write it here instead, right? Mid is a possible answer to our solution. So we don't want to eliminate it. So we want to keep this in the range. And also the other thing is that, okay, if mid is good, what does that mean? That means that everything to the right of the mid is also going to be good, as we kind of have this diagram. Everything to the right of the mid, or higher than mid, bigger than mid, bigger than mid is also good. So, but in this case, of course, we want to get the first true in this case, right? We're looking for this. So that means that everything to the right of this thing cannot be first true by definition, because the current value is already the first true, or it's not the first true, but it is already by definition. This is a possible first true. That means that everything to the right of it is not first true. So that means that we want to move the range, from here and here to here. So here, all we have to do is do right is equal to mid, right? And then else, what happens? That means that right is inclusive still. Right is still a possible answer. That's why right is equal to mid. And then now we move to left in that case in theory. Okay, because we basically chop off everything to the right of mid. Okay, and then now the other thing is, okay, what if mid is false, right? If mid is false, then one thing, right? Well, two things. Mid is not a possible answer. And also, everything to the, well, that's a little bit awkwardly. Oops. The page up key is too close to my backspace key. Yeah, and then now so now every I smaller than mid is also not good, right? So now mid is no good, and everything smaller than mid is no good. So we want to move left, which of course used to be here, say. We want to move left. Okay, let's actually, maybe I'll draw it here instead. Oops. So let's say this is left, right? Now we want to move it to here because we know that everything to the left is not a good answer. And of course, mid is also not a good answer. So then that left is equal to mid plus 1. So that's basically the idea behind this. And that's pretty much it. We run the code. Oh, did I not define it? Oh, I changed. I usually use the function name good, but I forgot that I changed it for this case. Cool. So this looks good. Let's run it for different cases. And that's pretty much it. I mean, we did the complexity at the beginning, so I'm not going to go over it again. But yeah, but this is a good warm-up to my binary search video, I suppose. I actually haven't solved this before, huh? It feels very familiar to another problem that I solved, or many other ones, so I don't know. But yeah, but it turns out I haven't solved this before, so it's a good idea. But yeah, that's pretty much it for this one. So yeah. yeah, that's basically all I have. Let me know what you think. You could hit the like button, hit the subscribe button, join me on Discord, leave me a comment in the comments if you really want to see a binary search video. I think I'm going to end up doing it, but you never know. So, put some likes if you really want that to happen. Yeah, that's all I have with this one. Stay good, stay healthy, to good mental health. I'll see you later. Bye bye.